Thank you. It's an honor to be here. So, authenticity of information has become a core issue recently due to the spread of false news. Research on the subject has shown that false news spread farther, faster, broader, and deeper than the truth in all categories of information. Machine learning is currently used to alter and forge content in ways that human senses are incapable of distinguishing the fake from the original. It is very important to be able to prove that your intellectual property existed before any plagiarized copy. That's Murphy's Law. But I refuse. And so the video was about
We saw the video.
Yes, you saw it, but I can't go forward. So I will go forward. So from a content creator point of view, protecting your copyright and your work and being able to prove ownership of digital content is key issue. So what about music? Music manuscripts stand out among written sources for studying our music heritage. The musicologist is often forced to examine different versions of the same work in order to study the compositional process. From this well-known composer whose impulsive writing style included numerous changes, corrections, additions, revisions to his materials, we see his struggle for perfection. The sonata, it's Sonata number 21 for piano, the non-Holstein. It originally included a long andante, and after revised by his friends to make it shorter, he took out the long andante and he wrote a shorter one, an introduction and adagio. Evidence of this cut and paste procedure can be seen on the sheet music on folios 14 and 15. Also, you may notice that the color of the ink is different. So that is really cut and paste in the analog world. So ink on paper is recognized as evidence for the existence of music composition. We're aware of the musical content even if the imprint has been erased, torn, burned, etc. Changes on the paper, additions, removals, etc. in many cases are used to reconstruct the compositional process. Actually, it's much more than 10 centuries that ink on paper has been used before being replaced by software. So from one big B of German composers, let's go to another big B. With the advent of digital scores and digital engraving, the original no longer exists, and thus no single source whose authenticity is impossible to dispute. Modifications to the digital file are not easily detectable, and identical content can be found in multiple copies. On the left, we see the manuscript for the cello suite number 1. We can tell this is not the composer's handwriting. Actually, it's Anna Magdalena Bach that wrote this part, and we can also tell that the scribe was determined to write this stuff. He did not erase, he did not change his mind, he wrote it. Probably he copied the music from another source. Very few composers write music at once in this way, and they usually are very great composers and they name universities after them. So the boundaries between the composer, the arranger, the orchestrator, and the engraver are hardly distinguishable. They often work on the same digital document. What happens to the archives? Long-term preservation of digital information requires confidence in the credibility of the archives. Ensuring that the provided information has remained unchanged over time is a particular challenge. Information generated today must survive long-term changes. So, which tools are we going to use? The best tool we can use is timestamping. Actually, trusted timestamping, which is a technique used to prove the existence of certain content prior to a specific point in time. Scholars very often use timestamping. We know terminus ante quem and terminus post quem. So we can date a source after or before something has happened, and we have dated that with certainty. If anyone, timestamping so allows anyone to prove without any doubt that specific content existed at a particular date and time. One of the most well-known and cheap ways of timestamping is called poor man's copyright. It's using registered dating by the postal office to date intellectual property. In simple terms, poor man's copyright means you take your original content, you put it in an envelope, you seal the envelope, you send it through the post office to yourself. And you make sure there is a clear timestamp on the envelope. You don't open the envelope until you have to prove that you had that content in your hands before that date. So if you need to prove it, you open the single envelope in front of a legal organization or a court or a lawyer, and then you can prove that you had your you had in your hand that content. There are also organizations offering timestamping services like the United States Copyright Office and many other copyright offices, which do the same thing. They are legal organizations that help you prove that you had in your hands your content. If you register with them, you give your work, and they can testify for you that at that date that work existed in their hands. But you have to pay a substantial amount of fees, and it's a centralized authority for registering our cultural heritage, meaning that if, let's say, a composer from Iran trying to register his composition to the US copyright registry, it's not, he might find obstacles. In the for scholars, using timestamp is also very usual. When we reference and cite our sources, when the source is digital, we timestamp it, saying when we had our last date accessed. For example, this program of the conference, if I reference it in my paper, I can tell what was inside it and say when I saw it, but 10 years from now, when this URL might not work, and probably it won't, it will be very difficult to say which file contained the information I used. We already know we have 4 versions of this program, and maybe there will be more. Thank God the organizers did not replace the original with a newer one. But the need is the same. So, what is the way? The way is using blockchain. In other words, distributed ledger technology, which has emerged as a means of storing information on decentralized networks secured from tampering and revision. In a few words, blockchain is consisted of a ledger, a catalog, a directory that includes timestamped records containing immutable data. Each record is linked to the rest and secured using cryptographic methods. The ledger is updated with the help of decentralized network The network is a collection of computers working and interconnected to one another. There is no central authority. The network is a peer-to-peer network, and actions are based on the principle of consensus. The information is public and freely available to anyone. Therefore, everything built into the blockchain is by its nature transparent, and all participants are accountable for their actions. The blockchain I am going to use is Ethereum. It's one of the many blockchains that are available. It's an open source, public, decentralized blockchain. It is a global computing infrastructure for digital contracts. So now how do we seal the envelope to store it on the blockchain? We have to use something called the hash function. Yes. And in order to save time, I would like to ask how many of you know what is a hash function? Yes? 50%. So, and quickly. All documents are ones and zeros. It's all digital media are strings of binary digits. A hash function takes any input, any digital media, and runs an algorithm and produces a fixed length, unique digital output known as the hash digest. It's this one here. The digest is usually very shorter than the original, and every time the same digital media is put through the same function, it produces the exact same output. Even if one bit changes, you may notice the A changed, the output is completely different, so different that you cannot tell what changed in the output, in the input, sorry. And the most important function is that it's one way, meaning that you cannot tell what was the input if you have the output. So that's our sealed envelope. We are going to store on the blockchain the digest, not the original. We can have the original hidden in our computer, in our treasury, anywhere. We can have it public, and if we want to verify that it's the same that I timestamped, we just have to compare it with the digest. The digest is the public one. So what's our goal? To create an intuitive way for timestamping engraved music using blockchain. With the same tools, we will protect our copyright for digital documents without disclosure. We do not have to show our content. Let's move on to the method. The method consists of storing a metadata record along with any document hash digest on the Ethereum blockchain. A JSON object means that it will extend the functionality of the blockchain, and verifying the metadata is simple. We retrieve the transaction content and decode the input data. We will see in the demo. Right after this, that the data is converted into hexadecimal code, which it's a bit ugly, but it's okay. So how do we validate? We just take the original file or any file that we want to test if it's the same, and we compare it to the digest. Everything I'm going to show is available at GitHub and my webpage in the front page. So I'm going to be using the Python package Web3, which is open source and was selected for interacting with the Ethereum blockchain. In databases, there are 4 ways to interact with data and records. They have the acronym CRUD. C-R-U-D, create data, read data, update, and delete. Create, read, update, and delete. So in blockchain, we can do only 2 of them. We can create and read. We cannot update, we cannot delete any of this stuff. I hope this is not too scary for people not used with coding. So I'm going to move on. Oh, I don't have internet, but I will fix it right away. And the display, just a moment. Mirror. Okay. Connected. So this is reading. It's written in Python. Actually, this is the preparation. I'm going to connect with a public node and ask stuff about this blockchain. I could run my own node. As I said before, running it is peer-to-peer. So if I want to connect to the public node, I need an API key. I connect to the blockchain. I get the transaction. I can right away ask for the transaction, see how it looks like. It's pretty ugly, as I said. So print me the transaction. One. Hello. Yes. Pretty ugly, as I said. That's my input. Let me show it. Input. That is what I have saved. I timestamped a composition from a Greek composer about 6 months ago, and I put some info in it. But now I will try to decode all this. That's what all the rest of the code does. So tell me the date I did it. It was June 28th. And tell me more about the input data you put inside. I'm going to ask for the data I put. I wrote the creator, the title, the source, etc. So run. There it is, my date, my composer, the name of the composition. This is where I saved the original so that everyone can see and validate. It was for validation purposes. I download it. Okay, that's the composition. It's in PDF format, but you can use any format you wish. Any digital media, and that's what I have to compare with. We're not going to verify it because we're going to create a new, yes, it's here. I'm going to create a new transaction. I'm going to timestamp a new file. So that's the JSON object I'm going to write. I use Dublin Core schema, and also I have saved the hash of this file. It's a demo file, so it's not worth mentioning. And what do? I convert it to hexadecimal, connect, prepare my data, sign it, send it, and print the ID. What is the ID? It is the receipt of my work. So this is where, if you remember, the first job we did was put this here. So let's ask now for this. Worthless one. A non-object has timestamp. What did I do wrong? I will ask another explorer. Reference law requires always thumb. So scan IO. Good. We're online. There it is. So my job was successful. It was done 40 minutes ago. Maybe I could not get results because there were very few confirmations. It costed about 1 cent of a dollar, and this is where I have my data. It's, as you remember, in hexadecimal, but I can convert it to human readable, and it's here. So this stuff can never be changed. It's there as long as the blockchain survives. And since this is a big one, it has many chances to survive for a very, very, very long time. I think I'm done. No, I need to verify, which is about 2 lines. This is my original, this is the hash. I download it and I compare it. If I get OK, means it's verifiable. If I change even one thing, it's not going to be verified. I'm going to get an error, and let's move on. Oh, just a minute. I want to change the screen. So, we're good. Evaluation. I'm not going to stay here. Most of this stuff was published last month by Springer, so you can see it and read it. The point is that this solution is secure. Store records are immutable. It's decentralized. I did not have to do with anyone, any third party. I don't have to involve with anyone else. It's public. My information is public available. It's open source. It's simple. I hope it was simple. And it's portable. And we do have interoperability. We have privacy. I can keep my file private. I don't have to give it to anyone, even not to a registry office. It's low cost. You saw it was about 1 cent. The Greek registry office charges about 30 to 70 euros for timestamping. The URL is timestamping.gr. And it's private. It provides, this is important, it provides added value to libraries, archives, and software. So if someone integrates a solution to his software, I think they're going to be 1 step ahead. What are the implications? With great power comes great responsibility. So hurry up. If it's so easy to timestamp your documents, hurry up and timestamp your intellectual property. Also, you have to timestamp work in progress, intermediate states of your content, and take care of private issues. I did not underline it enough, but there is sensitive information inside the code I showed. It's called the private key. It's part of the infrastructure, and if you lose the private key, you lose money. So be careful. I told you. I warned you. My point of view is a mindset shift on using the blockchain. It's very sad that most of people know blockchain as a way of financial transactions and not as a very strong and valuable tool to protect information and make it immutable. Internet blockchain is rapidly gaining traction. The effect that the web fabric had on the world during the 90s seems to me comparable to the impact of the information locking that blockchain provides today. Thank you.
Thank you very much for this new technology that we probably will all have to get used to. Are there any questions?
Blockchain is only secure if you have a large amount of nodes which participate, which are not controlled by a single person or entity. You avoided the problem of not enough nodes by using an existing network, but on the other hand, there is money involved, and Bitcoin has proven that if there's money involved, people are going to join a Bitcoin miner network And this minor network is controlled by a single entity, and there has been a point of time where they took over more than 50% of the Bitcoin network, and so it could control the process of agreeing on the next hash. And how are you going to avoid this?
Well, yeah, yes.
Second criticism is this environmental pollution blockchain. It takes a lot of computing power to calculate all this, and it takes a lot of energy. Electrical energy isn't cheap.
So this is on blockchain. This question is on blockchain. It's technical. I don't think this is the correct audience to talk about it. The financial part of it means that it's so secure that lots of people are willing to put their money in it. Right now it has 200 billion and it has not been hacked. It's unhackable. I'm talking about the big blockchains. That's it. The Bitcoin, I have to say the word, and Ethereum. From the environmental part, Ethereum is not only on the financial sector, and it's about digital contracts, and they are making quick steps to moving away from proof of work, meaning they have to pollute the environment and find other ways. But in my opinion, you have to have some way of paying people, paying the nodes who do the work for you. They are saving information for you, and they are locking information for you. So you have to have a way to attribute.
As long as there's not single biggest entity which controls all the nodes.
It's been 10 years now. The one who does it will win much more than our information and our timestamp. So it's a good thing. It has not happened yet.
Other questions?
Yes?
Your copyright will last, I think, 70 years after your death. We don't want to talk about that, but think about the people who get the copyright from you and 50 years after your death. So this may be some, I don't know, 100 years from now, have to prove that they do have a copyright. What makes you confident that at that time any Ethereum service will be running somewhere so that is not any good?
I am. Now, how can I prove this?
No, you can't prove it, you can only assume it.
I am completely certain this is going to happen, because even one computer exists on 70 years after my death, even one that has the full chain, you can prove it, because even one hash, one string hash can validate the complete blockchain up to the first one. It's a technical.
No, if there's only one computer left, then this one could forge anything it wants.
No.
It depends on having many to believe the truth.
I mean, even one computer that has the full history, and you know what was the last hash when the blockchain died. The last hash. Even if you have it, people are going to have it, then you can validate the full chain up the first one, and you cannot change it. People writing code know about these things from Git and GitHub. You cannot change things without knowing that even from the first line of code you wrote, that you made a change in a part of it. Now, about the copyright stuff, this helps only to prove when you created it. Copyright happens automatically. You don't have to do anything.
Sure.
It just happens. But you have to prove that you had your intellectual property at that time. That's all.
I would disagree with you on this point. If there is only one server left, having the whole history with it, then the guy who owns the server can fake all the hashes from beginning to end.
I am sorry, it is not possible.
It's very easily possible.
There are many programmers here that can tell about Merkle trees and the root of the Merkle tree, which proves the complete history with one string.
I can write a new history.
Yes,
And if you want to prove that
it will change the final hash. That's it.
Except if the hash algorithm is broken, of course. SHA-1 is already broken.
Yes, I think you saw that I used SHA-512, 512.
Yeah, but SHA-2 uses the same underlying concept as SHA-1. You should use SHA-3.
Yes, I did SHA-512. We have many, many years after my death. And we will have many other solutions. Yes. Yes, there was someone. Yes, yes.
I was just wondering, when you, maybe I'm just misunderstanding, so when you put input into the
Hash
hashing
function.
function,
Yes.
does it include any of the binary of some digital file, or is it all just metadata?
You can input anything,
Okay.
either binary or text, anything, digital, anything that has bits. Yes.
Intellectual property is at the core of what you said, and I was wondering, it can, of course, in our environment, talking about music engraving and the copyright of the composition, it can't be that you enter something like a PDF file in the funnel, because that, of course, does not represent the intellectual property of the composition. So what you need is you need an encoding that actually represents exactly and only the intellectual property, so that you can verify later that this is what has been copyrighted.
Or you have to preserve the original PDF.
Sorry?
Or you have to preserve the original PDF.
I still didn't get you.
Or you have to preserve the original PDF.
Yeah, but the original PDF will have some sort of graphic representation of the composition. But the copyright is not on the graphic representation,
Yes, but
it's
you
on
can
the copyright.
validate it using the PDF.
Well, I think there's
a print anyway.
yes.
No, but the point is that if you have another document that represents the same composition, but is not the PDF that you send
Yes.
to blockchain, then the copyright still holds, but blockchain will tell you this is not the same document, so you cannot prove the copyright in that process. So we have to have an encoding that really just presents the content that is copyrighted.
Thank you very much for the question. It's very important to distinguish what we can do and we cannot do. What we can do here is tell if a single file was in existence at a certain time, nothing more. Telling if that is copyright protected or this represents my intellectual property, thus this cannot be made automatically. It requires human interaction to judge, to compare and say these two look very much alike. I mean, if you change 3 notes, you cannot tell it's not your intellectual property. You can tell, people can tell, the computer cannot. So, thank God, computer is a tool. It's a way to prove things, but not judge.
It gives evidence, but not proof.
Yes, evidence, yes. Yes?
How would you explain this to governmental organizations?
It's something with electronics.
Good question. Well, there are already some courts that have accepted it as evidence, but since it is impossible to be changed and it's proven by math, by science, and by time, they cannot do otherwise. They have to, and we will help them to, because we are the academic community, and if we know the advantages of this technology, we can talk about it. Same happened with the internet 20 years ago. Nobody would understand what this thing, internet, how I'm going to sell things, and what is this e-shop, where is my front door, where I go from. Right now, the internet is everywhere, and you cannot switch off internet. You can keep people out of internet, but you cannot turn it down. There's another switch and take it off. Many would like to. Many try to, but same, I think, happens with this technology.